In our last video for section 10.2, we're going to take all the information we've talked about so far and add them all together into one. We're going to convert from radicals to exponentials. We're then going to use our rules for exponents to simplify. Then we're going to go back and convert it from exponential back into radical if we need to. So the steps for simplifying radicals is to convert it into exponential notation. Use your rules for exponents. Remember, all night my aunt ran mail downstairs. Simplify, and then maybe convert it back to radicals if we need to. Let's look at example 7. Use rational exponents to simplify. Do not use exponents that are fractions in your final answer. So I need to make sure that my final answer does not have fractions. Okay, A, the sixth root of 5x cubed. Okay, so that's in radical notation. Let's see if we can take that out of radical notation and put it into exponential notation. Because you notice I can't simplify it the way it is right now. I have 3 of these. That's not enough for a group of 6. But what I can do is I can write it as a rational exponent. Remember, top dog was in the house, so I can say that the sixth root of 5x cubed is really 5x to the 3/6 power. Top dog was in the house. Now you notice that 3 over 6 can be reduced. I can say that 5x to the 3/6 power is the same thing as 5x to the 1/2 power. Now that I've reduced it as much as possible, can we go backwards and convert back into radical notation? Because remember, we don't want any fractional exponents in our answers. So if I go backwards and I use my top dog was in the house to go back to radical notation, my 1 would be my exponent, my 2 would be my index, and I could say that my final reduced answer would be the square root of 5x. Remember, there's an invisible 1 here, and there's an invisible 2 here, but we don't necessarily have to write those two, we just know that they're there. All right, look at B. I have the 5th root of t to the 20th. Okay, so taking that radical notation, converting it into exponential notation, top dog goes in the house, would be t to the 20 over 5 power. Top dog goes in the house. Now wait a second, doesn't 5 go into 20? So I can really say that this is equivalent to t to the 4th power. My exponent isn't a fraction anymore, so I follow the rules. My exponent is positive, and I can't simplify it any more than it already is. So t to the 4th power would be my final answer on that one. C says that we have the cube root of a b squared c, all raised to the 12th power. Let's change this into exponential notation. If top dog goes in the house, my 12 would be my numerator, and my 3 would be my denominator. So it would look something like this, making sure that the a, the b squared, and the c all are raised to the 12 over 3 power in parentheses. Now 12 over 3 can be reduced, can it? So I can really say that I have the quantity a, b squared, c all raised to the 4th power. And then I can even simplify it more by making sure that I distribute this 4th root to all my different bases by multiplying my exponents. So I can say that my final answer is a to the 4th, b to the 8th, c to the 4th. They're all positive, none of them are like terms, and I have no fractional exponents. So that's my final answer on that one. All right, D says that I have the square root of the cube root of x. Let's take this one step at a time. Let's pretend, so let's do this. Let's pretend like this square root wasn't here. If that square root wasn't there, could I ignore that for a second? And could I really say that I have x to the 1/3 power? If I have x to the 1/3 power, now the square root's there, so let's put it back. I really have the square root of x to the 1/3 power. Well, can I take that square root and change this into a radical instead? Isn't the square root the same thing as a rational exponent of 1/2? So then I could say that I really have x to the 1/3 to the 1/2 power. The cube root is really the same thing as a 1/3 exponent, and the square root is really the same thing as a 1/2 exponent. So now I have this problem. I have 2 exponents. I'm raising to a power. Do you remember the rule? When we raise to a power, we really multiply, so I can really say that I have x to the 1/6. Now remember the directions say I don't want any fractions as exponents. So can I take that x to the 1/6 and convert it back to radical so I don't have any fractional exponents? If top dog goes in the house, I can convert it back to radical and say that x to the 1/6 is the same thing as the sixth root of x. So the square root of the cube root of x is really the sixth root of x. Using my different notations to convert back and forth, using my rules for exponents to simplify, and then convert back if I need to.